So, good morning, folks. I'm Jan. This is Shatadru. We're both from Workday, and we're here to talk about how to build a Zuul instance using the Zuul operator. This is going to be from a couple of different perspectives. So there's going to be a little bit for a bunch of different folks here. For anybody who's interested to be a user of Zuul or an operator or a developer in specifically the Zuul operator component. This is just a quick summary of what we'll be going through. First off, we'll just tell you who we are, what we do with Zuul, and why we're using the operator. Some of the options of hosting Zuul, if you're interested in actually running Zuul for your CI/CD, there's a couple of ways to run it. You don't necessarily need to use the Zuul operator to do so. An introduction, a little bit of behind the scenes on what the Zuul operator is and what it does. What you can expect if you use the Zuul operator in production, and also a little bit of a down the rabbit hole in an example of how to develop on the Zuul operator and work in upstream. So I'm Jan and he's Shatadru, and we're both from a team in Workday called the Workday Private Cloud team. You'll see the initials WPC. We tend to use WPC as an acronym every time. So if we accidentally call ourselves, talk about that, that's what you hear about. And now I'm handing over to Shatadru.
All right, so I'll be talking a little bit about who we are and what we do. So let me share some context about the team. So we provide very specialized infrastructure to run all the different Workday microservices. And we are running OpenStack Yoga. So I know that's a bit old, but hey, we just finished our upgrade from Victoria. Good. We use Calico for networking in OpenStack, and we have a lot of deployment tooling, and we use Ansible for our deployment. We have our build tooling, which uses Scala Ansible. So there is a little bit of some key highlights about our team and our scale. So we had 2 development Scrum team and 1 SI team spread between EU, mostly in Dublin, and the US. We have fairly big OpenStack deployment with more than 170 active clusters, and we have more than 100,000 concurrent VM, and more than 90 of our Workday internal microservices actually run on our platform. Even with this large scale, we have really high API success rate and VM uptime. So let's talk a little bit about Workday's like Kubernetes as Workdays. So different teams in Workday has been using Kubernetes apart from us, but Kubernetes in Workday WPC is kind of new. We have been building our new platform on top of OpenStack. So we are using Cilium for networking with the custom ingress. We are using Argo CD for our application and streamlining our deployment. And we are also using Cluster APIs, OpenStack provider for our Kubernetes deployment. So we are still kind of like polishing up our OpenStack Kubernetes deployment. Now, why Zuul? So why are we kind of using Zuul in our infra? So the simple answer is because we built OpenStack from source, and Zuul is probably the best choice for that, for its branch matching and multi-project dependencies. It's well suited for developing infrastructure, and it has excellent community examples. Apart from that, it's super easy to kind of start a new project or onboard a new project in Zuul, especially if it is Python or Ansible based. And because we use a lot of Ansible and Python for our deployment tooling, Zuul is like kind of the best choice for our infrastructure. So with that, I will end this to.
So we wanted to update our version of Zuul. So we've been using Zuul for close to 4 years now, and we haven't been updating it in a while, mostly because it's been working and we've been using it maximally. However, it's time for an update now, and we can solve a couple of problems at the same time. One of the things that we'd like is to have something that is a little bit lower maintenance than our current solution. Our current solution has a couple of manual, we still need to log into the machine. We'd rather prefer not to. We'd rather prefer a more managed solution on that. We also, for all intents and purposes, have something like a fully air-gapped infrastructure, which means that we can't necessarily just take an operator from the internet and apply it to our Kubernetes clusters. We'd have to make sure that we have the correct containers and everything. And finally, we also need something that is a non-trivial Kubernetes application. This is because we're trying to make sure that our Kubernetes platform is validated, so that when people start onboarding to services, they have a smallest shock as possible. So there's a couple of honorable mentions I want to pull out. These are things that we can that don't have or meet any of the previous criteria. If you want a fully hosted solution that you just buy off the shelf, Vexhost has one of them. If you have any kind of enterprise usage of Zuul and you're not interested in developing Zuul that much, give the folks at Acme a call. They specialize in these kind of things at operating it for you. Docker Compose and the OpenDev infrastructure. We basically took a copy of the OpenDev infrastructure for our version of Zuul. It is an excellent example if you need to find any high-class or production-grade example of how to deploy it. And it serves, it still services like an astonishing load that we can't ever reach. However, if you're interested in loading on Kubernetes, which a lot of people are, you have different options. So one of them is the zuul-operator. That's the one that we're talking about. There's also something called the software factory operator. Now, this is a team of Red Hat engineers who develop and work on that one. If you use OpenShift clusters, that would possibly be a better fit for you. You can also take Helm charts and do it yourself. These are reasonably valid options. Zuul is remarkably well suited towards a wide variety of scaling. You can run it from your laptop up to a production grade server and so on. And your system might vary extremely widely. You don't so much run a CI as build it yourself. So do it yourself is an absolutely valid option in this case. We chose the zuul-operator mostly because of a couple of factors. It's written in Python, so we have lots of available Python tooling for us since we build our own OpenStack distribution, basically. It has an all-in-one mode, which is extremely useful for us because Zuul requires a couple of dependencies like Zookeeper and database and those kind of things. And for the scale that we operate at, we can't necessarily justify making sure that we treat these as independent things. So we'd rather kind of pool the resources together and make sure that the operator can handle that rather than we task an SRE to handle a bunch of different services. So the community interest in the zuul-operator isn't a major thing at the moment, but there are a couple of folks that kind of like this specific use case. So it does scratch a particular itch. So it does seem to be a very specific use case that people kind of like. I'll hand you off to Shatadru to introduce us to the zuul-operator.
So I will touch lightly about some of the key features of the operator itself, and slightly discuss, like touch on the architecture of it and what it kind of does and what kind of like things it can solve for you. So so the operator itself can manage all the normal uh, Zool components like the executor, the scheduler, the merger, the web interface, the node pools. It can manage it all, and you can customize the configuration to have like the number of scales and different configuration. But also it can manage the dependencies like Zookeeper and the database. So we don't have to actually worry about like managing the Galera cluster or those kind of things. The Zool operator actually defines Zool as a custom resource. And you can like put configuration in the YAML. I will kind of touch a little bit about the installation. So the prerequisite of it is, of course, you have to have a Kubernetes cluster running and kubectl configured. And then you kind of need to just install the CRD, apply some RBAC, and install the zuul-operator itself. The documentation of the zuul-operator kind of explains this. It's not great. It would probably use some love from the community, especially the examples. And then you basically create your node pool configuration and your Zool configuration, and you put them as Kubernetes secret. After that, you define your custom resource, the Zool custom resource, as a YAML. You just apply that, and that's it. So that's kind of how you can manually install the zuul-operator and get started. So in our testing, we kind of like found like this is the easiest way to kind of like get started if you kind of want something really quick, to start with. So you just need to have Minikube installed, and only thing you need is a stable ingress. And once you do that, Zool actually has really nice playbook to get things started, which they basically use in the zuul-operator, use that in the CI. So you can just run this two Ansible playbooks, and this will basically get you started. So that's kind of like will give you like a small zuul-operator deployment, which we can kind of probably show in the demo a little bit later. So
Video is transcoded.
sorry.
Oh, the video is transcoded.
Yeah. So this is like a quick demo of the operator and the resources it basically deploys. As you can see, like it has the database. This is the logs from the operator, just to kind of show you like it's running. And then we have the scheduler, Zool scheduler, which again has been deployed by the operator itself. So just showing the logs.
This is an actual Zool running actual jobs as part of the CI.
Yeah.
Sorry, we'll do that just afterwards.
Yeah. And this is just like showing the configuration. I mentioned the custom Zool CRD. So this is just a configuration of that, which you can customize in your YAML. This has things like the connection to the your code repositories and things like that. So that's pretty much it for the demo. I will switch to the next slide. So this is something from our experience. What if you need to run the Zuul operator? These are some things you don't need, but this is like highly recommended based on our experience. You need some kind of GitOps CD to manage the operator itself. So we are using Argo CD, as I've mentioned previously. You definitely need some kind of external secret operator. There was a talk yesterday about like different operator. We are using the HashiCorp Vault for this, and you definitely need a stable ingress and persistent storage configured for it to work correctly. We also have some CLI action that we need to do, which we should probably fix up upstream eventually. And I will hand it over to Jan for the last bit.
So yeah, so if you wish to contribute to the Zuul operator, and this is highly recommended, it's pretty fun at some point in many respects. The first thing you should do is you should read the OpenStack contributor guide. Even though Zuul is not necessarily directly part of the OpenStack project anymore, it shares a lot of the DNA and history and policies. It's an extremely welcoming community. The local documentation for the Zuul operator to do some local development still needs a little bit of love, and that's an excellent documentation and contribution opportunity for folks. And the CI jobs themselves are actually super useful for anybody designing or trying to test an operator itself. I'll go through some explicit examples of why this is very, very cool. And if you get access to the slides, recommendation is go to that link. There's the history of Zuul, of how Zuul got developed, and the entire way that CI works is a fascinating read, and it is actually very, very cool. So for the summary of the CI, just as Shatadru described the manual installation process, the CI is actually just doing a slightly larger portion of that. In addition to this, it starts up a specialized build set registry. The build set registry there holds a bunch of artifacts that are intermediate. So instead of trying to, or the version of Kubernetes that gets installed there actually loads or prefers artifacts from the registry before it goes to the internet. So you get to test the same manifests that you run in production, but on the code that you are trying to test, which is extremely nice. You don't need to mangle stuff. The Kubernetes cluster starts up pretty quickly. It uses Minikube. It installs the operator. It runs an entire full Zuul setup and runs some Zuul tests nested inside it. It scrapes the output of those tests, and it scrapes the Kubernetes logs instead. So this is a kind of a timeline of how a CI job looks like. You'll notice that the Zuul operator upload image job, the one that's the longest over there, that's the one that stands up the intermediate registry and loads up the artifacts into it. The actual test that runs a Kubernetes cluster and the entire Zuul instance, that is the bottom job, and it is remarkably fast. The entire process is about 30 minutes to test an entire Kubernetes operator. These are the CI job logs. So this will obviously not make a lot of sense to folks, but it just goes to show you about the extensive logging that actually happens, just gets captured as a result of the entire process. See, there's a lot of complex things that are happening, and you kind of want to see where things go wrong. Specifically, this is a full dump of all the YAMLs of the entire Kubernetes, which is really, really cool. So you get to see if the operator did something wrong, or there is some pod not starting, what is the reason for that, and so on. These are the container logs, which is really cool because the operator is just a container. So you can go and see which section of your system is broken at a specific time or so. as you can see, this is kind of like a generic thing for testing any kind of operator, which is very cool. So there were some minor misadventures when we started evaluating the operator. We noticed that the gate was dead for a while. There was a bunch of different reasons for that, because a bunch of different things unrelated failed. And the good news is the gate is healthy now. Most of the fixes were mostly just update to the latest version, which is extremely nice. And there were some subtleties and rabbit holes that needed to go down and so on. But at least now we understand quite a bit of differences between Containerd, CRI-O, Podman, and Docker. If you want to, you can click on that link, and you can see every single misadventurous run of the CI, and try to replicate it in yourself if you want to. And I believe we just want to, at the end of this, we just want to thank the folks here at the lovely University of Indiana, folks at OpenInfra, and the folks at Workday for allowing us to speak about here. Thank you very much. Are there any questions? If not, we can run the demo at a slightly higher resolution.
So you mentioned earlier in the presentation that you were building OpenStack packages from source, and therefore Zuul was very well suited for the. If you weren't building from source, would you still get the same value, and would it be worth the effort to stand up that infrastructure?
The answer to that is going to depend on the scale of the number of clusters that you're building. You'll see that we are building like more than 100 clusters. So we have to ensure that things are super repeatable. And the greatest, or the biggest advantage that Zuul allows us is it allows us to test something that has not been committed yet. So specifically, we started our version of OpenStack without support for persistent storage like Cinder. And in order to roll out Cinder, we needed to be able to test it safely without breaking any of our production clusters, touching it. And without Zuul, we would not have been able to do that easily. We would have to craft and reinvent a bunch of dependency management things. We'd have to make sure that we'd have to fork our pipelines a lot earlier and so on. So Zuul made it a lot easier for us to be able to handle speculative work and de-risk it to such a degree that we were confident that we could deploy it without touching any existing workloads. That's super important to us because our workloads, our clusters run typically at like 90% utilization. And it's not like we don't have a lot of leeway there, and we have to maintain an exceptionally high level of stability for our services.
Just to add to that, the other thing is that we use a lot of Ansible and Python. So that's where also Zuul kind of fits well, because to test do like unit test and things like that, it's really simple in Zuul. You just have like 2-3 lines of code which can basically do linting and your unit test and all these things pretty easily. So if you have like your code base specifically in Ansible and Python, Zuul kind of makes a lot of sense, where you don't have to instrument a lot of things to get your testing done.
If you want to use VMs for testing, Zuul is one of the best.
Great, thanks, man. Appreciate it. And I will have the demo now. That to the session. You're okay with that? And that way the PDF of your slides will go through there.
Thank you so much.
Great, thanks so much. Let's thank our speakers. Thank you.